talking about how to rewrite exponents that are rational into a radical form and vice versa. So first, I'm going to give you the fill-in copy of this first part. So expressions with rational exponents can be rewritten as radicals using the following rules. If we have something that's like a to the power of 1 over n, n can be any number, a can be any number. What this really means is the nth root of a, and we would rewrite this as the nth root, so whatever number that n is with your root of a. If you have something like a to the m over n, this would be the nth root of a, so that part stays the same, raised to the mth power. So what I mean by that is we would still do this part the same, but then whatever the a is underneath the radical, we would raise it to the mth power. Okay, so let's do some of these so you see how that's done. So starting with number 1, we are writing these in radical form. We may or may not need to simplify. So x to the 1/4, just in case you can't see, that's what that was. X to the 1/4 would become the 4th root of x. Seems simple enough. It does get a little harder. Try number 2. 15n to the 1/2 would be, now here we usually don't put this 2 on the outside, but for the sake of this exercise, let's put the 2 there. You can erase it later. So it would be the square root of 15n, and if you want to get rid of that 2 on the outside, you could do that. Number 3, if we had something like 24 to the 1/3, so that would be the cube root of 24. Now we're looking at, can we simplify the cube root of 24? So you have to think back to your perfect cubes. 8 goes into that. The cube root of 8 is 2. So 24 to the 1/3 power is the equivalent of 2 times the cube root of 3. I know logically that doesn't really make sense, but if you work it out and simplify it, it will. Okay, let's do some more. 7 to the power of 2/3. So that would be the 3rd root of 7 squared. Now, if we just left this as is, right, we couldn't simplify it. But we can take 7 squared, which is 49, and then from there, so your perfect cubes, you have 8 and 27 and I think that's it. So this would be as simplified as possible. Right? Number 5, we have k to the 7/2. So that would be the 2nd root, or the square root, of k to the 7. Here is where it becomes something you need to simplify, because 2 goes into 7. So that means we could kind of break this down, because 2 goes into 7 3 times with 1 left over. So k to the 7/2 is the equivalent of k to the 3rd times the square root of k. Let's do another. 3 to the 5/4. So this would be the 4th root of 3, where 3 is raised to the 5th power. So just like number 4, we can do 3 to the 5th, which would be 243. And then from there, actually, we could do it this way, but there's another way. So I'll finish this way and then I'll go back. So now we know that 243 is a perfect cube. That doesn't seem right. It's 343. That's what I was thinking. But I can see if any of the perfect cubes go into this. So let's see, not 8, 27 does. Now 9 is a perfect square, it's not a perfect cube. So and 9 would not be simplified, but this would be 3 times the cube root of 9. The other way we could have done this is the fourth root of 3 to the 5th is the same thing as 3 to the 4th times 3 to the 1st, right? Because of our exponent rules. Well, 3 to the 4th, if we're using our rules, 4 goes into 4 once, so that would get brought out. Oh, and this was supposed to be, oh, that's also why I messed up. Hold on. I may have completely just messed this up. We're gonna just disregard that part with 1 3 left over. So if I did this correctly, which I did not, 243. So I have to know my perfect fourth roots, which I don't, but I can do 3 to the 4th, which is 81. And 243 divided by 81 is 3. And the fourth root of 81 is 3. There we go. That makes more sense. So we could do it either way. It's your preference. All right, let's move on to 7. So for 7, this would be the fourth root of AB to the 3rd. Now remember your exponent rules. If you have a power outside, you're multiplying all of your exponents. Your exponents here are 1. So this would become the fourth root of A to the 3rd, B to the 3rd. Or if you wanted to see what I actually did, 1 times 3, 1 times 3, so the fourth root of A to the 3rd, B to the 3rd. Moving on. Number 8 is going to be very similar to 7, but now we have numbers. Now we have the cube root of negative 6x squared. So that would be the cube root of negative 6 squared and x 1, or the power of 1 times 2, or squared. So we have the cube root of 36x squared. 36, I don't believe can be broken down anymore because it's not divisible by 8 and we can't divide it by 27. So that would be the final answer. And then let's do number 9. So here we have 7 times 12w to the power of 1/2. Think about your GEMDOS, PEMDOS, GEMS, all of those rules. Parentheses, exponents. So we can't combine 12 and w, then we have our exponent, so this would become 7 times the square root, or you can put the 2 out there, 12w. Then we could break down 12, since this is a square root, to 4 and 3. The square root of 4 is 2. We're going to bring down that 7 so we can multiply, and the square root of w. So this would become 14 times the square root of 3w. So I know you're probably thinking, how do we know when to simplify and when not to? Honestly, it depends on the problem. Look at it, see if you could possibly break it down more, see if there's anything that can be taken out. Worst case scenario, go back to your writing out factors. So like for number 8, for 36, I have, let's go with 18 and 2, 9 and 2, 3 and 3. This is a cube root, so I would need groups of 3, and I don't have groups of 3 here. X squared would be x times x. I don't have a group of 3 here, so nothing else would simplify. So it really just depends. Right, now let's do some of these ones down here. We're just going to do a few because really these are all kind of written the same. If you're given something in radical form and have to go back to exponential form, there's really only one way to really write it. So for number 10, the cube root of 16 would be the same thing as 16 to the power of 1/3. Number 11, the square root of x squared would be the equivalent of xy all, so we need parentheses, to the power of 1/2. If we were to just put xy to the 1/2, what's really being stated here is that y is being raised to the 1/2 and not everything. So we got to be very careful with that. And then last one we'll do here is number 12. The fourth root of 8w would look like this. 8w to the power of 1/4. I just realized that all of those didn't have a number in the numerator, so we'll do a couple of those. So 13, the cube root of 11 squared would be 11 to the power of 2/3. Whatever number exponent is inside, that would become your number in the top in your numerator. So something like 15. Now this exponent is on the outside, but it works the equivalent of if it were inside. So what you would do is still do 3m to the power of 7/2. So hopefully that makes a little bit more sense. Now we're going to get into the actual simplifying piece of this. So when we are simplifying expressions with rational exponents, we're going to rewrite all the radicals in exponential form. Because that'll just be the easiest. Use our exponent rules to simplify, and then write our final answer as a radical. That would look something like this. So we're going to start off with 19. This is in exponential form already, or exponent form, whatever. So if we are multiplying like bases, we are adding the exponents, so this would be the equivalent of x to the power of 1/3 plus 4/3. This is nice because we have similar denominators, so we can just add the numerators, x to the 5/3. Now that this is just one simplified exponent, now we can write this as a radical. So this would be the third root of x to the 5th. Hopefully you're with me so far. Let's do 20. Same thing, we are multiplying like bases, so we are adding the exponents. So we have p to the 1/4 plus 3/2. Now this one is not so nice because we have to change the fractions. Get them to be the same common denominator. We're going to multiply this by 2. So we have p to the 1/4 plus 6/4. And then that would become p to the 7/4. We're adding our exponents. Now that this is in its final exponent form, this would be the fourth root of p to the 7th. Okay, now let's try some dividing ones. we are dividing the same like base, so we can subtract the exponents. Again, our fractions are not the same, so we have to make them the same. So this would be m to the 10 over 4 minus 7 over 4, which would equal m to the 3 over 4. And then this in radical form would be the fourth root of m to the third. Next 22, raising a power to a power, we're multiplying the exponents together. So this would be a to the 1/3 times 5 over 2, or a to the 5 over 6. So then, writing this in radical form, we would have the the sixth root of a to the 5th. Right, let's jump into some more challenging ones, like 24. Okay. So again, we are multiplying powers together, but here we have an 8 and an x squared, so be very careful that you're doing this to both. So this would be 8 to the first times 2/3, x squared times 2/3. So this would give us 8 to the 2/3 times x to the 4/3. Okay. Now, if we were to write these as radicals, this would be the cube root of 8 squared times x to the 4th. Let's do this. We'll write it separately, then we'll combine it. Times the cube root of x to the 4th. Okay. Now, because these are both the same type of index, I could write them both underneath the same. So 8 squared x to the 4th. And then I'm going to go ahead and do a couple things. By itself, 8 squared cannot be simplified or taken out or anything like that with the index of 3. By itself, x to the 4th can. So I'm going to do one of two things at the same time. We're going to go ahead and make 8 squared 64. And then we know that 3 goes into 4 once. So that would be the equivalent of 1x coming out and 1x staying in. The cube root of 64 we know is 4. So this would be 4x times the cube root of x. So 8x squared to the power of 2/3 is the equivalent of 4x times the cube root of x. If you were to just say that to someone, that wouldn't make any sense at all. They'd probably be super confused, I guarantee you. Okay. Now if we do something like 25, this is 100 to the power of -1/2. So remember your negative exponent rule. When you have a negative exponent, that is the same thing as taking the power and flipping it, and then making that power positive. So this would be 1 over the square root of 100. You can put the 2 out there if you need it. We know the square root of 100 would be 10. Oops. So this would be 1/10. Let's skip 26, go on to 27. So now we have negative 216 to the power of -1/3. So same thing. This is going to become 1 over negative 216 to the positive power of 1/3. We can go ahead and change this to 1 over the cube root of negative 216. 216 is a perfect cube, otherwise I would say go ahead and take that negative out. So because this is a perfect cube, and the cube root of 216 is 6, this is going to become negative 6, or any of these would be fine, because as we know with slope, as long as one is negative, it doesn't matter. Number 28. So all the ones we've had with negative fractions so far have been whole numbers. What happens if it's a fraction? One, I would see, can you simplify said fraction? So I'm going to put that in my calculator. And I can. 112 divided by 7 is 16. So we'll do this two different ways. So if we can simplify it, do that. It'll make your life a little bit easier. And then from there, this would become 1 over 16 to the 1/4, which would become 1 over the 4th root of 16. And I want to say that's, no, I don't think that is a thing. Oh, it is. Oh, 2 to the 4th is, my brain, I was thinking 2 to the 5th. Anyway, this would be 1/2. Okay, the other way, I'm going to do this over here. So I'm going to rewrite it. 112 over 7 to the negative 1. Let's say we didn't realize we could simplify and we went from there. What would happen is we would end up switching the fraction as we would normally and making this to the power of 1/4. And then from there, you can't take the power of 1/4 or 7 to the power of 1/4 and 112 to the power of 1/4. So you would still have to simplify. This is just if you didn't see that you could simplify first. So this would simplify to 1/16. And then you could take each one. So this would be 1 to the power of 1/4 over 16 to the power of 1/4. Which would be 1 and 4, or if you wanted to rewrite it as the radical, this would be the same thing as taking the 4th root over 1 over 16, and then you still get 1/4. Either way. Let's do a few more of these and then we will be done with this video because I know it's getting a little lengthy. All right, for 29, if we have the radicals, I would suggest that you go ahead and make them into exponent form, like I said. So the cube root of v would be v to the 3rd to the power of 1/3. The square root of v would be v to the power of 1/2. And then this would give us, we are multiplying like bases, so we're adding our exponents. We don't have a similar denominator, so we would need to change them by multiplying. So we have v to the 2 plus 3 all over 6, or v to the 5 6. And now we can rewrite this as a radical. Let's do a different color. The 6th root of v to the 5th. Let's do 31. Right? So if we rewrite this, this would be 4 to the 1st power, if we're being technical, times, I'm sorry, not times, over the power of 4 to the 1/3. So we are dividing like bases, so we can't subtract. So this would be the equivalent of 4 to the 1st minus 1/3. These do not have the same denominator, so we would need to change that. So this would be the equivalent of 4 to the 3 minus 1 over 3. And then that would be 4 to the 2/3. Then you could go ahead and start writing that in radical form. Then the cube root of 4 squared. Again, like I said, 4 squared could not be simplified with the cube root, but I can make 4 squared 16. Now that doesn't really help us either, but we can break that down. Because we know, if I'm just thinking factors of 16, 8 and 2, 4 and 2, 2 and 2, we would have a group of 2's in there. Or you could think about it like this. Even though 16, we could have just broken it down to the perfect cube. My brain, I'm working too hard. So the cube root of 8 is 2 times the cube root of 2. And that would be our final answer. So 4 over the cube root of 4 is equivalent to 2 times the cube root of 2. Kind of doesn't make sense, but okay. 34 will be our last one. So for 34, we're going to go ahead and write this as exponents first. We have 25m squared all to the power of 1/4. We're going to take this step by step. We need to multiply the 1/4 to everything inside, so that would be 25 to the 1 times 1/4, m squared to the times 1/4. That would become 25 to the 1/4 m to the 2/4, or 25 to the 1/4 m to the power 1/2. And then if we were to change both of these to radical form, we have the 4th root of 25 and the square root of m. I feel like both of them. Okay, we're going to backtrack because we don't want that last answer. Okay. What we do want is we could break 25 down to 5 squared to the power of 1/4. We already broke down m to the 1/2. Because 5 squared and 25 are the same thing, I can multiply these exponents. So this would be 5 to the 2 times 1/4. So this would be 5 to the 2 over 4, or 5 to the 1/2. Now we have things that are the same exponent. So I can say this is the equivalent of 5m to the 1/2, since they both have the same exponent, which means this would be the square root of 5m. It's kind of weird to think all of that simplified to just the square root of 5m, but it did. Great. We are now done with that. You now have time to go and practice. Please come see me if you have questions, need help, if any of this did not make sense, any of that.